Good evening, ladies and gentlemen, on YouTube. Give me a moment. I'm getting the Facebook. Three, two, one. Okay, so our Facebook is up and our YouTube is up. All right, so welcome. And hope everybody's okay. I hope everybody's safe. Been having a rough week as a country um, with the issue. I'm not going to say the word. They say it messes with your algorithms, but everybody has a pretty good idea why we've been having a rough week. So hopefully everybody is out there being safe and just taking the proper precautions and things of that nature and stuff. So okay, so to all my first time viewers. Let me get myself together. This is the place where you bring your, for people that are prepared for the aviation selection test battery or the officer's aptitude rating in the Coast Guard, Navy, or U.S. Marine Corps. You bring the questions that you don't understand, and I solve them. In addition to that, for all my United States Army guys and Air Force guys, I do test prep for those exams as well, and ASVAB. So you can bring ASVAB questions to the table. I don't have an issue with that as until we get everything set up and everybody's going to have their own day, particular day. But Friday is the aviation selection test battery and OAR. Saturday is the SIFT, which is the standard instrument for flight training. Used to be the AFAST for United States Army rotary wing pilots. And but anything in between, uh, you know, ASVAB is more than welcome and stuff. As most people have problem with math, mechanical, and electrical, which applies to aviation selection test batteries, mechanical comprehension section. All right. I may cut it a little short today, but uh, we'll see. All right. Okay. So, questions, folks. First off, since this is the aviation selection test battery, most of you guys have issues with the math and mechanical, but I'm going to talk about a couple of nautical terms that you could possibly run into in the aviation and nautical information section. Okay, there's two terms. I'd like to talk about the freeboard and the draft. Okay, so let's go into it. The freeboard and the draft. Okay, so let's say we're in the water. Well, here's our craft. And this will be the first deck. All right. So this thing's in the water. Okay, so that is the water line. So there's two terms I want to talk about: the freeboard and the draft. All right. Now let's work our way from top to bottom. All right. The freeboard is the distance from the water line And this is where the water comes into contact, and the first deck. All right. So this is the freeboard. FRREBOARD. And the draft is the vertical distance between the water line and the bottom of the hull. So this will be the draft. Okay. And those are our two, freeboard and draft. Freeboard, first deck to the water line, draft, water line to the bottom of the hull. So every week that we meet, I'm going to be coming up with more and more aviation and nautical terms. All right. And in between there, Stacy. Good to see you, Stacy. Any questions? You know, you can post them. I'm looking at my post page now to see if anybody dropped any posts. And then I don't see anything yet. Okay. If you are following me on Facebook, you will have to. This is like a bit much. I can't really post this on. I can't like draw it out on the board. I can describe it. Okay. This pertains to the four-stroke engine. And the four-stroke engine, there's some things that go on during the engine cycle. A lot of you guys just go out there and you turn your key and you drive off and you're like, oh, okay, it's got oil, it's good to go. But there's a process. There's a timed process that takes place. And this is what this particular image is pertaining to. Okay. There it is. It looked like it didn't want to drop. That's like, hey man. All right. And Darren, I'd like to thank you for dropping the question, and then it looks like I may have something else here. All right. All right, Stacy, I'm looking at something you sent last week. All right. And this may be something, okay. All right. So yeah, just checking my comments. So this would be found in the mechanical comprehension section of things. There is a four-stroke cycle that occurs pertaining to engine operation. Now, I said I was going to do on the board. If you see the image, you'll see the crankshaft, and it's attached to a little armature that pushes a cylinder up and down. All right. And there's some things that happen. What you have is you have an intake port and you have an exhaust port. All right. And I'm going to try to do it as best I can. If you see the image, it makes more sense. But at let's see here. Okay. So we have W, X, Y, and Z. And these are different phases of the engine operation. So they're going to ask us for the proper sequence. So you have an intake valve and an exhaust valve. Okay, the first phase is intake. And during the intake, what happens is This opens to allow a fuel-air mixture in, and the piston comes down. All right, that's the intake. After it gets out of the bottom, this closes up because the piston is going to go back up. When it goes back up, this is sealed off, so the air and fuel mixture is compressed. All right, so that's power. So intake open, that's got to be Yankee, Y. Z, valves closed, and the piston is moving its way up. Valves are closed, X, and it's coming down. So it looks like Y, Z, X, and then it comes around W. Y, Z, X, W is the proper sequence. So what they're asking you for is the proper sequence. So Yankee, Zulu, X-ray, Whiskey is the proper sequence. So you see different phases. Yankee is the intake phase. The intake valves are open, the fuel air mixture in, the piston's coming down. At Zulu, the valves are closed and the piston is driving itself up and it's compressing the fuel air mixture, ready for the getting ready. So intake compression, power or combustion, and that is X-ray. So it boom, and it actually kicks the piston back down. And then at exhaust, the burnt fuel air charge is pushed out, and the exhaust port through the exhaust port. So that was an awesome question. And wow, my YouTube people can't really, if they can't see the image, that kind of sucks because you can't see it. But if you are on Facebook and you understood what happened, just type a 1 in the chat for me, please. Oh, this is a good question. And yeah, and then another thing I'd like to add, like right now is probably the best time to be studying for, whatever test that you're preparing for. Most people are at home, stuck at home, can't go to work, and so you have time to really focus a really, really good amount of time on testing. So, you know, it's just making the best out of a situation. Supposed to. Okay, moving right along. Okay, an aviation term, ground effect. Ground effect is a situation. Hold on. Okay, system of equation. Yeah, we can go over those as well. Okay. So yeah, ground effect. I wanted to talk about ground effect. Ground effect is a situation where is my little miniature airplane? Okay, so as this aircraft flies through the air, there is a normal upwash and downwash. All right. As the aircraft gets close to the surface of the Earth within one wingspan, or one rotor span if it's a helicopter, the Earth actually disturbs the airflow patterns. It you get less of a upwash downwash as the wing cuts through the air, and as a result, what happens is we lose some drag. All right, we lose some drag, and this drag or induced drag is lost, but you have the same amount of lift. So what happens is the airplane feels as if there's like a cushion of air, not wanting to allow it to land. Um, it is not a cushion of air. You just have the same amount of lift, and you have less drag, and that is ground effect. All right. So ground effect is the interference. Ground effect is the interference of the airflow patterns, the Earth's interference. Let's see. So ground effect is the Earth's interference of the airflow patterns around the wing. Verbatim. Ground effect is the Earth's interference of the airflow patterns about the wing. All right. And we have our next question. Our next question is a system of equations. System of equations are very, very cool, but you got to understand there's basically two basic forms of linear equations. It could be in y equals mx plus b form, which is slope-intercept form, the slope and y-intercept form. Or it could be in standard form, which we call ax plus by equals c. All right, so there's two forms that it could be in. Now, this particular question gives us both forms. The first equation is y is equal to negative 3x plus 5. That is the slope-intercept form. And then we have 5x minus 4y equals negative 3. All right, and that is the standard form, which is ax plus by equals c. In order to do system of equations, both equations need to be in the standard form, which is the ax plus by equals c. So this first one will be transformed, and I'll come over here. Now what's going to happen is the x is just going to come over, so we're going to have 3x. It goes from this side of the equal sign to that side of the equal sign, and becomes positive plus y, because y was positive, equals 5. So it's in the ax plus by equals c form. All right. Our bottom equation did not need to be changed. 5x minus 4y equals negative 3. So I have them both in standard form. Now I'm going to write it out in a different color because there's something that needs to happen. Okay. First, we might need to manipulate an equation. And I'm going to manipulate the top equation because we're going to have to add vertically. And we're going to have to manipulate it in such a way that when we add our x's, our y's, and our whole numbers vertically, that either x or y zeroes out. So I'm going to multiply the top by 4, which will make this positive 4. So when we add vertically, the 4y's will zero out. So 4 times 3x is 12x plus 4y equals 20. Okay, so we're going to forget about this equation for a minute because we've transformed it by multiplying each term by 4. Now we did that because when we add vertically, we want the y's to zero out. So that's why I chose 4. So I can isolate x. So when we add vertically, 12x plus 5x is 17x. The y zero out. And 20 minus 3 is 17. So that tells me that my x coordinate is 1. That's what we're looking for. So we're trying to find a point where these two lines intersect each other. All right. So after we figure out that y is 1, then we can substitute 1 for either equation. All right, for x. So 3x is 1 now, plus y equals 5. 3 times 1 is 3. 3 goes to the other side, becomes negative, so y will be equal to 2. So the coordinates that these two lines intersect each other at is 1, 2. That's the origin. All right. If everybody got that, hit 1, please. And that was a good question, Darren. Keep them coming. We did this one like a week or 2 ago. This in a previous live stream. And again, I don't mind answering questions, but I don't want to be doing repeats. Jonathan, good to see you. And Stacy, please resend that question, please, sir. I'm looking at my video. I'm like, wow, I got quite a few videos out. I'm laughing at myself. Excuse me, y'all. You guys. All right. So if you do questions, I've seen that one before as well. Okay, yeah. They're asking for aviation and nautical terms. All right, so let's take our ship from the top view. Now, we talked about the freeport and the draft, and someone has asked specifically about the. So let's say we have a boat or a ship. All right, this is the front half of the bow. This will be the rear or the stern. Okay. The right would be starboard. And the left side will be port. Now, the middle, say like these areas, will be the midships. Midships. All right. So, on the kind of, you got your starboard bow, port bow, starboard beam, port beam, and then your starboard quarter, port quarter. Okay. In front of the ship is a head, and this will be a stern to the rear. All right, and this is port. And I will actually provide an image. This image is brought to us by Freedom Sailing Scotland. All right, want to give people credit for their images. Nobody coming after me. And you can actually see it in the icon on the bottom right-hand side, Freedom Sailing Scotland. So if you're following me on Facebook, you can see the image. You go to stemwithkino.com on Facebook, just go to posts, and you will find it. But yeah, nautical terms are very, very important. I do get a lot of guys that come back with debriefs and say, yeah, man, they asked me for like the lowest level of the ship and things of that nature. So if you are preparing for the full aviation selection test battery, you're going to have the aviation and nautical information, ANIT, aviation and nautical information. So yeah, you can see the boat positions, bow, midships, stern, port side, starboard side. Starboard side is the right, port side is the left. And that was a good question. Okay. New question is dropping on the post board on Facebook. I can do this one on the board as well for my YouTubers that maybe don't have Facebook accounts. So give me a moment. Let me get this thing posted, and we'll jump in. Yeah, I got this thing down to a science. Now, I remember before I'd be like, oh my god, like this is too much. Now I can look on both sides and the Facebook channel as well as the YouTube channel, and boom. Alright, so I posted, let me refresh. Okay. What is the area of the equilateral triangle below? What is the equilateral triangle? An equilateral triangle or equilateral? Equilateral. I believe it's equilateral. But an equilateral triangle is a triangle that has the same sides. The angles are 60 degrees. All right. So as there are 180 degrees in a circle, but they're asking us what is the area of the equilateral triangle. What is the area? Okay, so equilateral, I think it's equilateral, but just imagine this is distance of 8 units, that is a distance of 8 units. Okay, our answers are 18 is A, 12 is B, 20 is Charlie, and 16 is Delta. So the area of a triangle is 1/2 base times height. Everybody type 1 if you are familiar with that being the formula. And I'll wait. Okay. So the base is 8. The height is not necessarily 8. So if we split this in half, this side will be 4. The Pythagorean theorem, we'll call this A squared, we'll call this B, and this C. All right, 1/2 base times height. We can't call the height 8 because it's on a slant. So that's why we got to draw a line, make that 4. And A squared plus B squared equals C squared. All right. C would be the hypotenuse, which is 8. And 4 would be the B for A squared. A squared equals 16 equals 64 plus 6 16 goes to the other side and becomes negative. 64 minus 16. 4, 48. 48. So A is actually, to get rid of the square, we lose the square and the square root goes over 48. Darren, what is the square root of 48? I see 1, 48, 2, 24, 3, and 1, 6. All right, root 16 times root 3, which would give us 4 root 3. So 4 root 3 is the altitude. Good job, 4 root 3. All right. So 1/2 the base, 8 times the height, 4 root 3. The base times height is actually 32. 8 times 4 is 32 root 3. And if we divide that by 2, we got to see which is the closest to 32 root 3. I see 16. Over 1 for the fraction side of things. So I think delta is the closest answer. Delta is the closest answer. Because let's see. I'm going to go on a limb here. Root 3 divided by 2. We rationalize the denominator. 2 root 3 over 4, which would be 1/2 root 3 over 2. The 16 would just be, the 32 cut in half would be 16. Root 3 over 2. So 16 is the closest answer. And I know that was a lot, guys. And I'm probably going to do a YouTube video really just breaking it down because I know that there was a lot there. But if you did catch it, type 1. If not, and you follow me on YouTube, I will do what I call a student feedback video. And this is just so we get as many questions as we can during the live stream. Okay, John. Okay, you guys. Okay, so it looks like you guys got it. Wow, that camera's kind of clear. I very rarely look at, the word. I'm looking for questions and stuff. So I'm like, wow, that's kind of. I'm looking at the board and different. All right. All right. Enough with the camera, Kino. Let's get to work. Okay, another aviation concept. The question you may get is when we know that there are 4 forces of flight. Even if you're in a helicopter, you have lift, you have thrust, you have drag, you have weight or gravity. All right, or weight. Let's just call it weight. And the question might be, when are the 4 forces of flight in equilibrium? And this is during level unaccelerated flight. Why? Because the vectors are all in balance. The lift vector isn't any stronger than the gravity or weight vector, and the thrust vector is no stronger than the drag vector. So it's in level unaccelerated flight. You're not climbing, descending, and you're not speeding up or slowing down. So when are the 4 forces of flight in equilibrium? During level unaccelerated flight. Okay. Stacy had a question. All right, Stacy, hold on. And Stacy had an electrical question. When I looked at that question, you will have to have a working knowledge of. I mean, I've never really seen anybody come out with a question that deep, electrically speaking. But let me tell you, well, you will have to know, and I will expand on this as we go, week after week after week. Your parallel and series circuits. So, Stacy, let me ask you a question, and you can respond. Let's just say I have two circuits. One circuit here. That's a circuit. Another power source. So, crowd participation. Type 1 if this is a series or parallel. If it's a series, type 1. If it's a parallel circuit, press 2. And anybody can type that in. It doesn't have to just be Stacy. All right, I see that. So this is the parallel. I'm sorry, this is the series, this is the parallel. You will need to know that the difference is there's only one path for electrons to flow in a series circuit. Like a TV series, one episode after the other, or one component after the other. So there's one component after the other, like a TV series circuit, one component after the other. In a parallel circuit, there's more than one path for your electrons or your current to flow. So you can see it's like you get your power source and you have two extra ladders there. All right. I know I can go through this till I'm blue in the face, but the Ohm's law triangle. I teach the Ohm's law triangle as a memory aid so you understand what to do. Should you ever be presented with a circuit and you have to find current, resistance, or voltage. So here is the Ohm's law triangle. V goes in the top, split I, R. Ohm's law states that voltage equals current times resistance. Now, the symbol for voltage is V. The symbol for current is I. And the symbol for resistance is R. Voltage is in volts. Current is in amps or amperes. Amps is short. And resistance is in ohms. I always want to go, oh. So, the reason why we have the Ohm's law triangle, because I use this as a teaching tool, but a memory aid as well. Mathematically, if we put anything side by side, that implies that we're going to multiply. So if I want voltage, if I'm looking for voltage, boom. Voltage equals current times resistance. If we're looking for current, I. In mathematics, if something is on top of something, it's division. So V divided by R, or voltage divided by resistance. And if we're looking for resistance, we hide the resistance. And resistance equals voltage divided by current, which is I. All right. So, Stacy, you can type in yes for the question I'm about to ask. Do you understand Ohm's law now? Because I want to creep in. There's a whole lot of background And I am going to answer your question, but there's a whole lot of background and some things that you need to know before we get there. All right. So, Ohm's law triangle, voltage equals current times resistance. And it's not only helps you remember what the law is, Ohm's law, but it also is a memory to teach you how to find voltage, current, or resistance. So type in yes if you got that so far. And for my YouTubers, type in 1 if you guys understand Ohm's law. Please. Okay. Very good. While we're here, the mechanical. A lot of times I come into contact with you guys throughout the week. And I always ask you guys, well, what are Sir Isaac Newton's 3 laws of motion? And for our purposes, I'll touch on that while we're here. All right. Number 1, the first law, the law of inertia. An object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. This is the law of inertia. Inertia is the tendency of an object to stay still or keep moving. So this mouse I have in my hand has a certain mass, and it's not going to move unless I push it, pick it up, or something. So an object at rest will stay at rest, and an object in motion will stay in motion unless acted upon by an outside force. So the mouse will not move, so I pick it up or push it. Now imagine I'm not going to do it, but imagine I just knocked it out of my hand. Well, the acceleration of gravity is going to take over, and it's going to start to fall. An object in motion will stay in motion unless acted upon by an outside force. It's going to fall and fall and fall, and eventually the floor is going to say stop, acted on by an outside force. So for Isaac Newton's second law of motion, for our purposes, force equals mass times acceleration. Now, force is in newtons, mass is in kilograms, and acceleration is in meters per second squared. It's very, very important because we just say meters per second, that's velocity or speed. We say meters per second squared, we're talking about acceleration. And my people know the importance of this. When I say my people that tutor with me throughout the week. Because I'm constantly hammering, no, that's acceleration. No, that's velocity. No, no, I don't beat them. What I'm saying is I place a very strong emphasis on being able to differentiate between the two. Because let's say, and this is not uncommon, let's say we work something out. And matter of fact, you know what? Since we have Ohm's law of triangle, all right, boom, VIR. Okay, we have a power source, 10 volts. And we have a 5 ohm resistor here and a 5 ohm resistor here. All right. So we want to calculate the current. We have 5 ohms of resistance here and 5 ohms of resistance here. Darren, what is the total resistance in this circuit? Anybody can answer. All right. Darren's going to enter 10 ohms. He did. He responded via Skype. All right. So there's 10 ohms of resistance. So we want to know, given we know our voltage, and we want to know our current going through the series circuit. So our voltage is 10. Total resistance is 10. So 10 divided by 10 is going to make our current 1. 1 ampere, or 1 amp. We say amp for short. Now, this is not uncommon. I'm sorry, I was looking at my little email pop-up thing. Let's say you have 1 amp, 1 volt, 1 joule. Your units are important, because if you get the 1, oh my God, there's 1, and you pick 1 volt, your units are wrong. So we always want to know the units that we're working with, and we want to always make sure. And that's another thing I always beat my guys up with and everything. So Stacy, I want you to stay tuned to next week, because we're gonna go ahead and we're gonna go deeper into that. All right. So yeah, like I said, I am gonna close a little bit early. I just want to remind you guys, this is the best time if you're prepared for the ASVAB, Aviation Selection Test Battery, OAR, AFOQT, United States Army SIF. This is the best time to be doing it. Your distractions are like at a minimum. A lot of the businesses and stuff, they shut down early. Just get as much study time as you guys can get in. Seriously. Because this thing's not gonna last forever. And these recruiters are gonna be gunning for you guys. They're gonna be like, hey man, you ready? What have you been doing with all that free time you had? So make sure you guys plan. So I'm gonna close out. I thank everybody for taking time out to come and check me out. Please let your recruiters know about my channel so they can send more people, and we can ask more questions and stuff. Because really, I would prefer you guys just have them on the post so I can just knock them down. And I say this every week, but nobody listens to me. Nah, it's all good. Either way, I know you guys have lives and you're busy and you're doing stuff. So that's all I have for you guys. Again, study hard. This is, a time where you can take advantage of it. Get your books and you can lock down. And you don't even have to do it just, study for an hour, watch TV for an hour. Study for an hour, do something you like for an hour. So you got that, that ebb flow. Not Law and Order marathons, because that locks you in, or me at least. So, all right, I'm out of here, guys. Thank you for checking in, and I will see you guys soon. Bye-bye.